Okay, guys. As introduced in class today, we went through the triangle angle sum theorem. I'm just going to reiterate that here. And there's also two other theorems that I want to talk to you about. That'll be in your homework packet. That'll be due on Wednesday. So for the triangle angle sum theorem, again, that theorem says if a figure is a triangle, then the sum of the interior angles is exactly 180 degrees. Right, exactly. Is exactly 180 degrees. And this goes for every triangle. I mean, the triangle could be this small to this huge to the size of the pyramids to etc. It doesn't matter. Every single triangle, the sum of the interior angles is always 180 degrees. So I'm just going to give you a picture to go with the theorem again as I did in class today. So here are my three angles in this triangle. So this theorem says the sum, so sum is addition, of the interior angles, so that means the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. And again, that goes for every single triangle in the entire universe. Now, you again are already knowledgeable of this theorem. Everyone's done this in the lower levels. So again, I'll show you an example of what you would have seen at the middle school, elementary level. You would have seen a triangle, for instance, like this, where this one might be 70, this one might be 58, and you're asked to find the missing angle. They won't even have a variable there. Normally it'll just be a blank. But for our sake, we'll put an X there. So again, what you would have done at those lower levels is simply just 180, subtract the 70, then you can come back and subtract the 58, and you would get your answer. But the way we're going to do even this problem, we would probably make it more of an equation, but it doesn't matter. If you did it via an equation, it would be x plus 70 plus 58 equals 180. That would be like the equation, quote unquote, setup of it. And then you would get x plus 70 and 58 is 128 equals 180. Then you would subtract the 128 from both sides, and you would end up with x equals, it would be 52. 52 degrees here. And that would be our answer for x. And again, whether you did it the first way or this way, it doesn't matter. Answer is 52. But again, this type of question is on the lower level of ability. Like this is very simple, very basic. So how do we elevate this to make it more of a geometrical concept where our subject is pretty much the study of all shapes? So for us, this will be like more elevated. It'll be something maybe along these lines. Excuse me, where this might be, say 40. This is, let's go with 75 degrees. And then let's say, actually, it probably wouldn't be like that. Let me not give you this one here. Let me not give you this angle. Something like this. And this will be like, let's say this is 120. And then I'm asking you for x. Now, most of the time, I will just have it just like this, where I won't even have an extra variable over here to make you even think to find it. If there is a variable there, then it's probably a little bit more obvious as to what the progression would be. But a lot of the times we will not put that there. So this will be the problem where you need to find x and y. So in this case, again, moving more towards an elevated problem, a high school level problem, a geometry level problem, you have to connect the fact that these two are forming a straight angle, a linear pair, supplementary, etc. Any of those words that trigger it for you. But these two here are supplementary. These two here are a linear pair. So you could do 180 minus the 120, and you'll figure out that y is 60. And then once you figure out that y is 60, then you'll use the triangle. So this is the triangle. And for the triangle, again, we just talked about the sum. Whoa, sorry. We just talked about the sum. And the three angles would add up to 180. So we would do, again, you don't need to write a formal equation, but if you are comfortable with an equation, it will be x plus the 60 plus the 75 equals 180. Again, I don't need you to do it. I just want you to get comfortable with it because soon you will have to do it. So it'll be x plus these two together equal 135 equals 180. Subtract the 135 and you'll get that x equals 45. So that problem is a little bit more of a high school level geometry problem using the triangle angle sum. Let's try another one, example 3. For example 3, let's get even a little bit more geometry forward. And let's take this. I'll say this is 53. This is x. This is y. Let's go with 28 for this one and 85 for this one. All right, so I want to know x and y for this one. So for this example, again, we're basically practicing triangle angle sum here. So if you were to look at what we have here, we have two different triangles. We have this one that I'm going to outline in yellow now. And we have the other, the purple one. Now for this yellow triangle, that's where I need my x and y. And I'm at a dead end here. I have a triangle. I know all three of them equal 180, but I don't know, I only know one of them. So there's no way for me to, at this point, figure out what x and y specifically are. So I would be at a dead end with the yellow triangle. But what I should recognize is that the purple one is also a triangle. And with this purple one, I know that these three angles have to equal 180. So even though, again, this is what I'm saying, like I probably won't ask you for this angle here, but you need to, I may erase it. You need to realize that I need to figure out this angle here. Even though it wasn't asked for, I'll put, let's say I'll put an M in here. So I'll find this angle M first, because what you should connect here is that these angles are, in fact, vertical. And what you should know about vertical angles is that vertical angles are congruent. So if I can figure out angle M, I therefore know angle Y, and therefore I can figure out X. So this is how the geometry makes these problems a little bit more challenging, because you have to know how angles connect and what you can do and what you can't do. So I'm going to now work with the purple one, and I'm going to do 180. So again, I can just do 180, subtract the 85, subtract the 28. Perfectly fine to approach it that way. Or my other option is to, again, write it out like an equation. If I wrote it out like an equation, it would be M plus the 28 plus the 85 equals 180. 28 and 85. What's that going to be? 93, 113? 113 equals 180. Oops, sorry. Plus 113. Plus 113 equals 180. Subtract the 113. Subtract the 113. We end up with M equals 67 degrees. So that's my answer for M. Excuse me. Grab the calculator. All right. So now that I know that M is 67, I know Y is 67. Because again, vertical angles are congruent. So now I can find X, because X plus 53 plus 67 equals 180. And we're going to do this. We'll get X plus, these two add up to, it's going to be 120 equals 180. And I end up with X equals 60 and 67. so those are my two answers for X and Y. So again, this is a question, not crazy difficult, but this is a geometry application of the triangle angle sum. We did a few other examples in class today, like I think this is page 4 here. We'll do one more if you would like here. So this is, I think it's page 4 from the packet, but we'll do number 4 here from the packet today in class, and then we'll skip around and do a couple different types, another different formula. So for this one, if we look at number 4, again, we need to find 3 different variables here. We have X, we have W, and we have Q. It's up to you which one you approach first. You could go for Q. I'm going to do it a little differently this time just to show you a different approach than what we were doing in class. Don't need to confuse you. So if you're more comfortable doing it the other way, sure thing, go do it that way. But if we were going, if we were going about it with the bigger triangle, sorry, whenever you touch the page, it goes back out. Oh my God. Let's see if we can keep it. Okay, let's see what happens this time, guys. Okay, good. All right, so I'm gonna go with this huge, not the huge, I'm making a smaller point here, with the big triangle. So if I go with the big triangle, what I need to understand is that these 3 angles, so this one, and this one, I'm not trying to mark them congruent, so let me adjust that. These 3 angles have to add up to 180 because it's one big triangle. Now this one's already 57, so it's 57 plus, this is my Q, and then these two, because this angle at the top is made up of the 28 and the 35 together. So when I add those two together, that's 63. The 28 and the 35 is 63 when I add it up. So then that has to equal 180. So I'm doing the big triangle. So if I did the big triangle, those two add up to Q plus 120 equals 180. So I end up getting that Q is 60. All right. Then once I get Q is 60, I still need to go back out and find the other variables. So it doesn't matter which one I do first at that point. I'm going to go ahead and go for X. So since I'm going for X, now I'm going to use this smaller triangle on this side, where these 3 have to add up to 180. So again, I don't need to write the equation. I'm just going through the process and, being more step forward with the work. So it's 57 plus 28 plus X equals 180 for this red triangle over here. So the 57 and the 28 add up to 85. So it's 85 plus X equals 180. So you end up getting the X is 95. And then these two are a linear pair. So these two have to equal 180. So this is going to be 85 for W. All right. All right. So the additional theorem that I want to introduce to you guys now is called the remote exterior angle theorem. Actually, there's one more. Let me do one more thing before we do that. Let's do one more. Let's say example 4. So let's do one more type of triangle angle sum application. The other type that you'll see with the triangle angle sum, that'll be more, high school level, will be something like this. So for this type of one, I'm going to tell you that this is, let's say this is 8x, this is 5x plus 15, and let's say this is 3x minus 5. So, and then let me put some letters here. This is angle A, angle B, angle C. So, something like this would be another elevated problem on using the triangle angle sum. Now, for this particular problem, triangle ABC, we know that the 3 angles, again, have to equal 180, the sum of them. So if I was trying to solve this equation, so basically what it would be, I'm sorry, I didn't say here. I want you to solve for X. And I also want you to find, let's say, the measure of angle. Let's go with angle A. So if I ask you to solve for x here, what you need to do is think about what you know about these angles. You know that 1, 2, 3, when you add them up, that has to equal 180. So your equation should be 5x plus 15 plus 8x plus 3x minus 5 equals 180, because the triangle angle sum theorem says that these three angles, when I add them up, have to equal 180. So this would be my situation, and then I would solve this resulting equation. The solving should be something to in your wheelhouse at this point. We combine like terms. So 5 and 8, that's 13x, plus the 6 is 16x. Combine these like terms, a constant, so that's 15 and negative 5, so that's going to be plus 10. So then I solved, I minus 10 from both sides. I end up with 16x equals 170. Divide by 16, it's going to be a decimal, just round to the nearest tenth. All right, so I'm going to do 170 divided by 16. And I get 10, it's 10.625, but I'm going to round it to 10.6, just to the nearest tenth. For any, not say for any, but 90%, 99% of the problems, I'll probably tell you guys to round to the nearest tenth. So that can be, our MO, just to pretty much do that. And now I ask you to find the measure of angle A. So since I'm rounding, I'm going to plug in what I rounded. Okay, so make sure you don't, some people put a decimal, they round, but then they still use whatever came up in their calculator. So you want to make sure you use the rounded value. And then I'm plugging that in. So it's going to be 5 times 10.6 plus 15. So this is, if we're thinking about our properties, this is our substitution. We're plugging in here. So it's 5 times 10.6, 53, and then that plus 15 is 68. So the measure of angle A is 68 degrees. And x was 10.6. Okay, so that would be another like high school level problem on this level of triangle angle sum. All right, so the last thing I wanted to give you guys a little bit of notes on, and this is also covered in our packet, is the remote exterior angle theorem. Remote exterior angle theorem. And what this theorem says is the following. In a triangle, the sum, wow, what happens when this stuff happens here? The sum of the sorry, let me go back. I don't like the way that's worded. The exterior angle, I shouldn't say an exterior angle, in a triangle, the measure of an exterior angle is equal to the sum of its two remote interior angles. Okay, so let me explain this. Let me give you guys a diagram, and then I'll go through and explain it for you. So this is the diagram we're going to use. It's a little wonky there. All right, so here's our diagram. All right, so this is my triangle. I'm going to just label the insides as X, Y, and Z. And then I'll do the outside angles as A, Now, when it comes to this remote exterior angle theorem, this is what it's saying. It's saying in a triangle, the measure of an exterior angle is equal to the sum of its two remote interior angles. So first of all, let's make sure you understand what an exterior angle is. The interior angles are these angles here, like angles 1, 2, and 3, the ones that are inside the triangle, or in this particular diagram that we have, X, Y, and Z would be the interior angles. So the exterior angles are, in this diagram, A, B, and C. So this is saying that the exterior angle, so in this case, let's start with angle A, is equal to the sum is addition, of its two remote interior angles. So if I'm looking at A here, I'm starting with A. A is equal to the sum of the two remote interior angles. The remote interior angles are the angles it doesn't touch. So Z is the adjacent interior angle. So it's not that one. It's going to be the two remote ones. So angle A is going to be equal to angle X plus angle Y, because those are the two remote interior angles. Now, there's three separate statements because there's three separate exterior angles. So if I moved on to angle B, all right, I'm just going to use different colors because this eraser is just going to keep messing up the picture here. Excuse me. So if I use angle B, so now I'm talking about this one outside here. So for angle B, I'm going to use the yellow. The two remote interior angles from B, again, it's going to be the two interior angles that it does not touch. So this is B, the interior angles are X, Y, and Z. The two that it doesn't touch are going to be Y and Z. So angle B is equal to angle Y plus angle Z. And then we have one more that we would write for C. So angle C is equal to, and for angle C, the two remote interior angles, again, are the two interior angles that C doesn't touch. So here's C. The remote interior angles that it doesn't touch would be X and Z, because it's touching Y here. It's adjacent to Y, so it's going to be the other ones. And let me explain to you why this theorem works. We'll prove this theorem on today, Monday, so we'll prove this theorem on Thursday in class. But let me just explain to you, kind of with some simple numbers, why this is going to work. So let's say that this angle out here is 110. And this is 60, and this is 50. And I ask you for X. When you are trying to figure out X here, again, this would be a pretty straightforward example. If I'm trying to figure out X, I could have done it two ways. The first option would have been to know that X is a linear pair with the 110. So I could have just done 180 minus the 110 and figure out that it's 70 that way. The other choice would have been to use the triangle. Because the triangle, I know that these three together have to add up to 180. So it would have been 6x plus 60 plus 50 equals 180, because these three had to equal 180. I would have x plus 110 equals 180, subtract, and I would get x is 70. So if we think about it, if these two have to add up to 180 because they are linear pairs, supplementary, straight angle, etc., if these two have to add up to 180, and then these three have to add up to 180, then it's going to be a given that these two are equal to this one because of that connection of them having to equal 180. The 2 together equal 180. The 3 together equal 180. So this is kind of the reason that happens. So how does this help you, knowing this remote exterior angle theorem? To be honest, a lot of the times you can work around it. You don't need to necessarily know it. So for an example like number 2, for instance, it would be easier if you knew the remote exterior angle. If I asked you for x, and I said this is 38, and I said this is 59, let's say, and I asked you for x. Now, you don't need to know the remote exterior angle theorem. You could just do the work and figure out what this missing angle is with the purple dot. Let's say let's put a z here. We could figure out z first. So we could say 180 minus the 59 minus the 38, and we could figure out z that way. So 180 minus 59 minus 38, and we get an 83. And then once you get z, again, these are a linear pair, so you could do 180 minus the 83 and figure out that this is 97. I'm sorry. Yeah, 97. It's 97. Now, the other option, if you did the remote exterior angle theorem, would just have been to add these two up, because the remote exterior angle theorem says that this exterior angle is equal to the two remote interiors. So you could have just done 59 plus 38. Add these up. 7 carry to 1. It's 97. So it saves you some time. Is it a necessary time saver? No. But again, it is probably going to make your life a little easier. All right, so that's it. You guys should be able to, at this point, go ahead and work on the packets. Have a great day, and I'll see you Wednesday in class.